Good morning, everyone.
Good
We
morning.
have 5 participants.
Morning.
Good morning. We have 5 participants. I'm going to go ahead and mark attendance. Take a look. 2, 3, 4, 5. Okay. All right. Last class, we have learned a new function, logarithmic function. Y equals log with base b of x. That's what does a logarithmic function look like. This equation has 3 parts. The first part is the base by the ratio of log, and b is the base. We need to know the names for the 3 parts in the equation that represents a logarithmic function. And x here is called the argument. Okay, and the y here is the logarithm actually. But I'm gonna leave this. I'll just write logarithm here. Logarithm we learned, or we introduced the logarithmic function as the inverse of exponential function. Based on that fact, this equation is equivalent to b to the power of y equals x. Okay, so those two expressions, those two equations are equivalent. Y equals log with base b of x is equivalent to b to the power of y equals x. And let's look at the 3 parts in the equivalent exponential form. This is the logarithmic form. This is the exponential form. B here is still base, right? And x is the argument. So x is the argument. X actually is the exponential function. And y is a logarithmic. Logarithm. So I can just say y is log, okay? A trick to remember how do we convert from one form to the other form. It works for me. I don't know if it works for you. I'll just introduce this trick. So y is the log, right? Y is the log. And you know, log also represents a piece of wood, remember? So we can imagine y is a piece of wood. Then the base is carrying a piece of wood on the shoulder. So y actually is also the exponent. Does that make sense? It's just something that I come up with, can help me to remember how do I convert from one form to the other form. Y is the logarithm. In short, you know, we can say y is the log, is the log. Log can also refer to a piece of wood, right? You know, a log cabin, those piece of woods make the cabin. So y is a piece of wood, and the base is carrying a wood on the shoulder. Just imagine a worker is carrying a log on the shoulder. So that might help you to remember y is the exponent. The log is the exponent. If the base is carrying the log on the shoulder, and b to the power of y equals x. In both equations, we have 3 parts. And if we know two of the parts, we should be able to find the name for the third. For example, if I give you this, can you tell me which part is the, can you tell me the names for the three parts? Yeah, how do we say B? That one is easy. How do you say B? What's the name for B in this equation? This equation defines a logarithmic function. You might wonder, what is the star? What is the triangle? It's just the quantity. It's just the quantity. Just want to put something abstract there. What's the base, guys?
B, right?
Yeah, B, the base, exactly. And what is the argument?
The star,
Yeah, what's the log?
the triangle.
Exactly. So if we want to convert this equation to its equivalent exponential form, then we would have the base carrying the log. Since you know the triangle is the log, right? Log a piece of wood on the shoulder of the base equals an argument, right? That's how it works. So this is how do you go from logarithmic form to its equivalent exponential form. What if we do the other way around? What if we need to do, if we are given exponential form, how do we rewrite the equation in its equivalent logarithmic form? So in this equation, B is still the base, right? B is the base. That part doesn't change. And knowing whatever on the shoulder of the base, that's the log, right? X is the log. Since we only have three parts, the three parts are base, argument, log. So now we already found the two parts, base and the log. Of course, that makes Y has to be the what? Argument. Does that make sense? We only have three parts in the equation: base, argument, and log. If we can find the two of them, then we know the other one. What's the other one? The remaining one. So now we have B is the base, X is the log because X is on the shoulder, Y is the argument. Then we can write that equation in the equivalent logarithmic form. So log with base B is always the base, and the argument is Y equals log, which is X, and done. I'm trying to show you the trick I use to convert from one form to the other. Please let me know if that is clear.
I understand it.
Okay, very good. Thank you. And one thing I want to point out, actually is very important, is the argument. Okay, is the argument. So in the exponential form, the argument is the y. The argument is the exponential function. As you can see, y is the argument. Y equals b to the power of x. You know, b to the power of x can never be negative. If you remember the graphs we had last class, last Thursday, exponential curves, exponential functions, whose graphs always located above x-axis. It can never assume a negative number. Has to be strictly bigger than 0. So from here, we can have a very important conclusion. The conclusion is argument has to be strictly bigger than 0. It's important, so we should write it down. Argument should always bigger than 0. As you can see, y is the argument, right? Y is b to the power of x. Is the y value, the dependent variable, the value of the dependent variable of an exponential function. Exponential function, b to the power of x, always above x-axis. So the argument always bigger than 0. Can never be 0 or negative. Has to be strictly bigger than 0. So here comes a very important conclusion. Argument always positive. Argument is always a positive. All right. This conclusion is very important because it helps us to determine the domain for some logarithmic functions. Let me see if I have some of the similar problems. The domain for logarithmic functions. Bear with me. I don't have it here, but I can give you one very quickly. For example, if you are given a log function y equals log with base 2 parentheses x plus 7, okay, this is a logarithmic function, right? Base is 2, log is y is the log, right? And of course, the other part, this part, is the argument. We only have 3 parts in the equation that represents a logarithmic function. Base, log, argument. Base is 2, log is y, so argument is x plus 7 as a whole. As a whole, is x plus 7. Remember, argument has to be always a positive, cannot be 0 or negative. So the argument has to be greater than 0, strictly greater than 0. And we solve this inequality, minus 7, then we would have x is bigger than -7. And x is bigger than -7 is the domain of this logarithmic function. X could assume any numbers bigger than -7 to past infinity. That's the domain of this function. All right? So this is important. Since we are looking at the relationship between the two forms, and we can see the argument as the y value of b to the power of x has to be always positive. So that's the reason we can make this conclusion. Argument is always positive. And we can use this conclusion to find the domain for some logarithmic function. Just to make the argument strictly bigger than 0 and solve the inequality, we would have the domain. Okay, and then let's look at the conversion between the two forms again. If we are given a logarithmic form, we have to identify the 3 parts. B is always the base, the star would be the argument, right? And then the triangle is the log. Remember, log is a piece of wood, should be on the shoulder, of the base. So we can convert to b to the power of triangle and then equals the remaining part. The remaining part is the star, is the argument. The other way around, if we are given the exponential form, b is still the base, right? I don't see a reason you don't see which part is the base. B is the base. Then whatever on the shoulder of the base, that's going to be the log, a piece of wood. Since we already have the base, we already have the log, then the third part, the remaining part is the argument, then y would have to be the argument, right? And once we have the 3 parts identified, we can write the equation, the function in the logarithmic form. So log with base b, argument is y equals log. Log is whatever on the exponent, right? X. Okay, let's actually do some problems. This one, number 2. Write the equation in exponential form. Assume that all constants are positive and not equal to 1. Means b is positive, not equal to 1. So b can be the base. Okay, this one, okay, I might misspeak something. So b is not base here, okay? So look at this equation. And look at this equation and tell me, does this equation looks a little bit different from other, logarithmic function? Do we have a part missing? Do we have a part missing? Let me tell you, B here is not base. B here is the argument. Okay, B here is the argument. Base has to be by the foot of the log. Do you agree we are missing the base? Do you agree we are missing the base?
Yes.
Yeah, okay. So when you see the base is missing, that means it's a default as 10, 1, 0, 10. When a logarithmic function has a base 10, we call that logarithmic function as a common logarithmic function, common log. All right. So when you see the base is missing, that actually means the base is 10. On your scratch paper, you can write it out. Log base 10, and the argument is b, and m equals m, right? And you can write the 3 parts. You're gonna write the 3 parts. Obviously, 10 is the base. 10 is the base, and b is the argument. M is the log. Only have 3 parts: base, argument, log. Our goal is to rewrite the expression, the equation in the exponential form. Okay, base is b. I'm sorry. Base is 10. I apologize. Base is 10. Base is 10. And then remember, log is a piece of wood gonna go on the shoulder of the base. Okay, equals argument b, and that's the equation in the exponential form. Okay, so you just enter b equals 10 to the power of m, or 10 to the power of m equals b. I don't see the difference. Left side equals right side, that gives you right side equals the left side. So which side first doesn't matter. Which side on the left or right doesn't matter. So that is number 2. Number 3, write the equation in logarithmic form. Assume all constants are positive and not equal to 1. Okay. The given, I think that's not 8. That might be S. Give me 1 second, let me double check. Yeah, that is S, not a 8. Okay, so we are given exponential form. It's easy to identify 7 is the base, right? Yeah, 7 is the base. And the S on the shoulder of the base, that is the log. R, we only have 3 parts, remember? We already found our base, already found our log. Of course, the remaining part is going to be the argument. So this one is the argument. Once we have the 3 parts identified, we can rewrite that equation in its equivalent logarithmic form. So log base, yeah, look at what you have wrote on the scratch paper. Base is 7. Okay, 7 go here. And the argument, yeah, we have the argument. Argument is R. Go here. Equals log. Log is S. Done. Do you think you can do it? So just remember 3 parts: base, log, argument. Base, log, argument. Okay. The next one, number 4. Write the equation in logarithmic form. Assume that all constants are positive and not equal to 1. Okay. This one is in the exponential form. Let's find the 3 parts. Base definitely is 10. Remember, the thing on the shoulder of the base has to be the log. The piece of wood is very important. And that's how do I remember it. So I hope it helps you. Then the other one would be the argument. Z is argument. We have the 3 parts found, and we can write the equation in the logarithmic form. Log with base 10. Argument Z equals log m. Done. So it's okay. You do not have this 10 here. That's fine. You do not have 10 there. That means the log is common log, is default as base is 10. So sometimes you don't really have to write it, but I believe if you write it there, if you put a 10 there, it will not mark it wrong. It's still correct. So basically is log z equals n. Base is 10, but we don't really write it out. Common log. So far so good, guys? Let's move to the next problem. If you have any questions, just let me know. Number 8, evaluate exponential functions and logarithmic functions. So this topic is about given the input and find the corresponding output for those two types of functions in this chapter. The function we have here is f of x equals 5 to the power of 2x minus 1. Base is 5. The exponent or the log, on the shoulder is 2x minus 1. And that's the function. The f of x is y, right? So it's the output. So it's just a calculation. It's a calculation. So let's see, how do we find the f of 3? When the input is 3, how do we find the output? We just need to replace x with 3. We have 5 to the power of 2. Plugging in x equals 3 here, and minus 1 equals 5. 2 times 3 is 6. 6 minus 1 is 5. And you just need to use a calculator to figure out what is 5 to the power of 5. Do you guys have a TID for a calculator? A scientific calculator should be able to do that as well. But the recommended calculator for this course is TID4. So I'm going to raise 5 to the power of 5. I got a 3,125. You only need to enter this in the cell. Those parts should supposed to be on your scratch paper. F of 4, same thing, just plugging in. Yeah, this question is pretty straightforward and basic. 5 to the power 2x minus 1. Plugging in x equals 4. 2 times 4, 8. 8 minus 1, 7. We just need to do 5 to the power of 7, right? See, 5 to the power of 7. Uh, 78,125. This is an exponential growth function, is increasing. The reason is the base is bigger than 1, so it's increasing. This is an exponential growth function. So when x is getting bigger, the value of the output is getting bigger, is increasing. As you can see, even just 1 unit bigger, the y value, has gone up so much, right? Has gone up like 25 times bigger, 25 times bigger. This exponential growth. Next one, find the exponential function f of x equals c times a to the power of x, whose graph goes through the points 0, 2 and 2, 8. All right. So we have two unknowns in a given function. We need to find out what's the base, what's the value of the base a, and what's the coefficient in front of the exponential function. Yeah, what's the value of c? We have two unknowns, but we have two given points. We're gonna just plugging in. Okay, the equation that represents the function is y equals c times a to the power of x. Let's plugging in 0, 2. Let's plug in 0, 2. So x is 0, y is 2. When y is 2 here, c, a, x is 0, right? And let's simplify a little bit. So we have 2 equals c, a to the power of 0. A here is supposed to be non-zero as the base of the exponential function. A has to be bigger than 0 and not equal to 1, right? So anyway, a is not equal to 0. That gives this part 1. If a is non-zero, then raise that part to the power of 0, we would have 1. So we have 1 here. And you know what? Actually, we got the value of c already. Value of c is 2. Value of c is 2. Okay. So the function now is y equals 2 times a to the power of x. We still have another point we can plug in. In this case, we're going to plug in x equals 2, y equals 8. Okay, y equals 8. Bring down the coefficient 2, and the base is a, x is 2, so a squared. Divide each side by 2. We have 4 equals a to the power of 2. And anybody can tell me what's the value of a? Anybody can tell me what's the value of a?
2.
Yeah, exactly. What about -2, guys? What about -2? Can a be -2? No. Yeah. You see, I just highlighted the condition for the base of an exponential function. As the base of an exponential function, same with the base for a logarithmic function. The base has to be positive and not equal to 1. So a, even -2 to the power of 2 is also equal to 4. But since a is the base of the exponential function, it has to be positive 2. So we got it. A is 2, c is also 2. Okay, that's a coincidence, by the way. It doesn't always, have the two things equal to each other. It's just coincidence. So that is that problem. Next, find the exponential equation whose graph passes through the points -3,3/64 and 3,192. Find the exponential equation whose graph passes through the given 2 points. All right. This problem is very similar with the previous problem. The previous problem guide us better. And this problem given even less information. So similar with the earlier. We're gonna let the exponential function as y equals c times a to the power of x. Okay. Now let's plug in the first point. Plugging in x equals 93, y equals 3/64. Let me write it down. Plug in x equals 93, y equals, I believe that's 3/64. Okay, then we would have y equals 3/64 equals c times a to the power of x, which is 93, right? That is one equation. And if we plugging in the second point, which is x equals 3, y equals 192, then we would have another equation. Y equals 192 equals c times a to the power of positive 3. Positive 3. So how do we solve this system? This actually is a system of equations. Not linear because it's exponential. Hold on. Yeah, it's not linear. So what am I gonna do? Sorry, what am I gonna do is this, okay? What I'm gonna do is I'm gonna use 2 to over 1. Let's see what happened. On the left side, if I use 2 to over 1, I would have 192 over 3/64. Yeah, 192 over 3 over divided by 3/64. And I can keep changing flip, right? And I would have 192 times 64 and there's 3 on the bottom. 192 divided by 3 gives, I'm going to do this on a scientific calculator. Let me grab a calculator. So 192 divided by 3 is 64. So 64 times 64 is 4,096. That's the left side. And what happened to the right side? If I use 2 to over 1. Right side of 2 is C, A to the power 3. Right side of 1 is C, A to the power -3. C cancels, C canceled, right? And you remember how do we get rid of the negative exponent from foundation 2? We can flip A to the power -3 on the top of the fraction bar in the numerator and get rid of the negative sign. So we should have A cubed times A cubed, that is A to the power 6. All right, so after we do the quotient, make a 2 to over 1, this, and we have the left side equals this number, we have the right side equals this number, right? And we have A to the power 6 equals 4096. And how do we find A? In the calculator, we can do A equals 4096 to the power 1 over 6. Is the sixth root of 4096. Basically, we need to find a positive number whose sixth power is 4096. And I'm gonna do that. 4096 to the power 1 over 6, 1 divided by 6. And that gives me 4. Okay, yeah, that makes sense. Because remember here, earlier, this is 64. So 64 times 64. And 64 actually is 4 cubed. And this one also 4 cubed. So this number 4096 actually is 4 to the power 6. 4 to the power 6. 4 cubed is 64. Another 64, 4 cubed, so 4 to the power 6. And so A equals 4. Well, finally. It's a little bit time consuming, right? And once we have the base found, then the function now becomes y equals c times 4 to the power of x. And what's the value of c? What's the value of c? We can use whatever the value you feel more comfortable. Since the first given pair of points has a fraction, most of people don't like fractions, we can do the second one. So plugging in y equals 192, x equals 3 again. So we have 192 equals c times 4 to the power cube. 4 cubed is 64. And c here would be equal to 192 over 64. 192 over 64. Is a 3. So c is 3. The final answer is y equals 3 times, what is our a? A is 4, right? 4 to the power of x. And you're going to enter this part in the cell because they already have a y equal given. You're going to enter 3 times 3 dot 4 to the power of x. A lot of algebra. Yeah, that's the challenging part. Any questions, guys, so far? Okay. Next. Number 4. The table below shows values from the function f of x equals b to the power of x. Identify the base. Identify the base. Okay, so what do you think? Here, when x is 92, y is 4. So the base, I like to use b to the base because b is the initial of BASE. So when x is 92, the corresponding output is 4, right? When x is 91, corresponding output is 2. When x is 1, the corresponding output is a half. Yeah, actually, this actually tells us what's the b, right? Yeah, this actually tells us what is b. b is a half. Half to the power of -2 is 4. Half to the power of -1 is 2. Half to the power of first power is half. So that information gives us the value of the base. And next, find the logarithm. Find the log. Okay, find the log. Multiple ways to get it done. Okay, find the log. So find the value of this logarithmic function. One way to get it done is to let log with base 2 of 8 equals x. So we want to know the value for x, right? We are not very familiar with log function. Relatively, we should be more familiar with exponential functions, right? We have done exponential expressions since foundation 2. So one way to get it done is to convert this equation. I made this equation happen, right? We are only given an expression, but I let the right side be x. Then we have an equation. Let's convert this equation to the equivalent exponential form. You know, 2 is the base. See if you can do this. 2 is the base. 8 is the argument. Right? X is the log. Yeah, the log that we are trying to find out, right? So once you have those 3 parts identified, we can convert that to the equivalent exponential form. Base to the power of log equals, you know, the remaining part is the argument, which is 8. Think about which number would satisfy this equation. Which number would make that equation be true? Or 2 to the power of what gives 8? That's a very simple exponential equation, you know. 2 to the power of x equals 8 is 2 to the power of 3. So cancel the base b, cancel the base 2, we have x equals 3. So x is 3. Means this log is 3. And that's how do we find it out. Right? The base is 2 to the power of 3 log. Log is 3, so 2 to the power of 3 is the argument. 2 to the power of 3 is the 8. I hope you see it. You know, everybody knows 2 to the power of 3 equals 8. I believe you understand this equation, right? It's a identity. Then in the future or gradually, you need to be able to see this is a true statement as well. Because base 2 is going to raised to the power of the log, which has to be 3 in order to give you 8. Gradually, you need to be able to see that very quickly. 2 to the power of what gives 8? That's my point. As a beginner, I would recommend you do what I just did. Identify the base, argument, log, the 3 parts, and then convert to the exponential form, and something you're more familiar with, and find the value of x. And next, similar, evaluate using your calculator, giving at least 3 decimal places. Do you guys have a calculator, by the way? You need a
Yes.
Okay. So the class in the syllabus, we recommend TID for calculator. So look at, okay, I'm gonna have to stop share this note and then go share my calculator. This is an emulator on my computer. Should be look similar with yours. And do you see this key, log? That's the common log function. Means the base is 10. When the base 10 is missing, that means it's defaulted as 10. It is a common log. So this key And my big arrowhead is pointing this log. That's a common log. And right below it is ln. ln, 2 letters, is the natural log function. Means the base is e. Oh, you wonder, what are you talking about? Well, since I'm already sharing the calculator, I couldn't really write anything. I'll tell you later, okay? So log, remember, is the base is 10. So what are we trying to look for? We're trying to find the value for log 330. Yeah. One good thing about the TID4 calculator is you could really literally enter the expression in the calculator. Whatever you see on the question, you would be able to see the exact same thing in the calculator. 330. So it starts a left-handed parenthesis. That means you need to enter the argument in the parenthesis, which is 330. And you need to close the parenthesis to make the complete. And then enter. So that's the value. And then you properly round it. I believe you know how to round a number. And then the next one is ln, okay? ln 0.482, okay? ln, as I said, is a natural log function with base e, letter e in egg. I'll explain later when I'm able to write. So just know, common log and the natural log, they are very important. That's why they have 2 keys on a calculator. Any calculator have those 2 buttons. And the argument that is given is 0.482. 0.482. Again, we need to close the argument, close the parentheses, and you will have that number, right? And then properly round it. Next question is to find natural log with argument negative 0.002. Let's see what happened, okay? The argument is a negative 0.002. Let's see what will happen. Natural log, start the parentheses. The parentheses is going to frame the argument. Is a negative. Okay. By the way, this is the negative sign. This is the minus sign. You do not use minus sign when you need to enter a negative number. If you use minus sign, it's not gonna work. This is the minus. This is the negative sign in the parentheses. Negative. What is the number again? 0.002. 0.002. Let's see what's gonna happen. Okay. Natural log with argument negative. Let's see what happens. Error. What does that mean, guys? Non-real answer. Why would that happen, by the way? What happened to that? The beginning of today, we have a very important conclusion. The conclusion says argument has to be what?
Greater than 0.
Correct. That's the reason the calculator shows is non-real or is error. Yeah. Because the argument is negative. All right. So let me stop share the calculator. Let's go back the note. This is my note. Oh, this is my note. All right, I believe you know how to do this one. Common log, this one, natural log. This one, you just write, does not exist, I believe. Does not exist. Because the argument cannot be negative. Argument has to be positive. Okay. Now let me introduce the natural log. Natural log has base e. So when you see ln, let's say 0.482, that actually is log with base e, 0.482. And what is e? What is e? E is the famous Euler number. Euler is a German mathematician. Was, of course, passed away. Is a very famous irrational number. irrational number. Means it is a decimal, non-terminating, non-repeating. Non-terminating, non-repeating. Pi is the most famous irrational number. Pi is the most famous irrational number. And then the second famous would be the E, the Euler number. Is about equal to, that's what I remember. I have to check. Let me check quickly. What is the value of E? Yeah, I was right. 2.718 to A1A to A, yeah. It's non-repeating, by the way. It's an irrational number. It's about equal to 2.718. 2.718, yeah. Pi is around equal to 3.14, right? And E is about equal to 2.7. It's a very important number, irrational number. When you go to calculus, or actually you probably see this in foundation 2 for the compound interest problem, when the interest compound continuously. All right, so let's continue. Number 9, transformation of exponential functions and logarithmic functions. So this topic is about the transformations of those two types of functions. Draw the graph for f of x equals negative, base is 1/6 to the power of x. So this is exponential. The mother function is y equals 1/6 to the power of x. And then we just need to reflect with respect to x-axis, like a mirror, and we would have the function we are going to draw is a negative 1/6 to the power of x. All right, so we are going to draw the mother function first. It's gonna be decay, by the way, since the base is between 0 and 1. It definitely passed this point, 0, 1. So when x equals 1 is 1/6, very small. You know, it's only getting smaller and smaller. When x equals -1 is 6, -6. Okay, we need to guarantee those two numbers, those points has to be, at least those 3 points has to be in the right place. And we connect them. I believe in Lumen is easier for you because you have a better tool. And here, completely just manually draw the graph. This is the mother function 1/6 to the power of x. And we're going to flip that with respect to the x-axis, the horizontal scale, which is the mirrored, right? So we're going to have here, and here, you know. And the red one is the function. Okay, give me Okay, I'm back. Sorry about that. This is the first graph, exponential function. Exponential decay, but after we flip over the horizontal scale, we actually have a, I don't know how to say that. It's not gonna be exponential. It's not an exponential growth, by the way. Is this weird curve? When x goes to infinity, past infinity, the y value get to very, very close to 0, but never equal to 0 or go above. So always negative. So that's the curve. Next one, draw the graph f of x equals 1/3 to the power of x plus 3. Mother function is important to identify the mother function. The mother function is y equals 1/3 to the power of x. And how do we, do the transformation to get the daughter function with the exponent x plus 3? So the 3 is added to x, right? So it's gonna be a horizontal shift. It's shifted to the right or shifted to the left, guys? Plus 3 here. Shifted to the right or shifted to the left? This one is a little bit anti-intuitive. We have seen similar before. So shifted to
The left.
left, yeah. Shift to the left. 3 units. All right, so let's find some points. So 1/3 to the power of x. Let's do the mother function first. I'm gonna use blue. It's gonna be a decay. Definitely have this point 0, 1, y-intercept. When x equals 1 is 1/3. So we need to get this point done correctly. Not that difficult to divide the 1 unit as a third part, right? So we would have a point here. Oh, yeah, a little bit bigger now. So when x equals -1 is positive 3. When x equals 92 is positive 9. Yeah, those are good points. Those are good points. And that should be enough for us to draw a very good curve. Exponential decay curve. It has the x-axis as the horizontal asymptote. Now we need to shift the blue curve to the left 3 units. What we can do is we have 1, 2, 3, 4. 4 of the important points on the curve, on the blue curve. So we're going to shift the 4 blue points to the left 3 units first. And this one is going to 1, 2, 3 is going to be here. And this one, 1, 2, 3 is going to be here. And this one going to be 1, 2, 3 be here. And that one, 1, 2, 3 going to be here. Right? And then you connect those points. The horizontal asymptote is the same thing, okay? Horizontal asymptote is still the y-axis, still the x-axis. So that's the curve. All right, that's the curve. Shifted to the left, the red curve is the function. Represents the function that is given. Next, find an equation for the graph sketched below. So previous 2 problems were given the function, we need a graph the function. And this problem is we are given the graph and we need to find the function. So let's see. What does this function look like, Find an equation for the graph sketched below. I'm gonna do this. I'm gonna first flip with respect to the x-axis. Find some point. This one, this one, and this one. So if I flip, I'm gonna have, that's positive 5, so I'm gonna have -5 here, and also have it here, and that's -4,6, -4,96 gonna be here about. So if I flip, I'm gonna have a curve like that. And that seems have this x equals -6 as horizontal asymptote. Okay, so the red curve does look like exponential, and with y equals -6 as the horizontal asymptote. So, and that is going to be, how do I use a different color? So the blue curve is this one. If we shift all the points above, shift upwards for 6 units, and we have this point here. We're gonna have this 1, 2, 3, 4, 5, 6 here. 1, 2, 3, 4, 5, 6 here. And yeah, we should have a curve like this. And that's exponential. That's exponential. So I would say the function is going to be exponential. So it's look like this. And the c is going to be negative because it flipped with respect to the x-axis. And also shift downwards 6 units. And the base, let's see what's the base. I see this point. When x equals 3, y equals -2. Let's try to use that. Then we have y equals -2. This is -3 to the power of x minus 6 plus 6. We have 4 equals -3x. And divide by -1, -4, 3 to the power of x. And the x, hold on a second. Shift it downwards and then flip. Maybe this one. Three comma -2.
Wouldn't you substitute x for 3 instead of b?
Oh, yeah, you're right. You're right. So y equals -2. So if we flip first and then go down. Flip it first and then go down 6 units. It's better. And negative bx is 3. minus 6. So this is 4. 24. Cube is 94. I need to find a better points here on the graph. Give the downwards 6 units. And we also have this point I notice. That is 1, 4. 1, 4 is better for sure. 1, 4. 4, 1. So 12. 4 equals 90b plus 6 plus 6. 10 is negative 10. Okay. Is negative 10. Of course, cannot be negative 10. One, 4. Y-intercept is 0, 5. So when x equals 0, yeah, this is positive. So basically, is y equals negative b to the power of x minus 6. Shift downwards 6 units and then flip. When x equals 0, that's 1. 1 minus 6 is 95. 95 times 91 is positive 5. Okay, this is the right one. And then we plug in x equals 1, y equals 4. 4 equals negative b to the power of 1 plus 6. And 4 equals negative b plus 6. Negative 2 equals negative b. Okay, equals 2. All right, finally. So y equals negative 2 to the power of x plus 6. That's the function. Let me double check. 0, 5, 0, negative 1 plus 6, 5. Okay. And 1, 4, when x equals 1, negative 2 plus 6 is 4. And we also have a point like a 3, negative 2. When x equals 3, 2 to the power 3 is 8. Negative 8 plus 6 is negative 2. Okay, that definitely is correct. This is definitely correct answer. And a little bit troublesome. So how do we make it easier when you see this type of problem? I think we'll have to sometimes explore the y-intercept helps, and we know here is actually plus 6. Is shift down 6 units first and then flip with respect to the x-axis. Okay. Next question is a logarithmic function. We need to graph this function below. First, locate the vertical asymptotes, then plot 2 points on the graph. Mother function, y equals log with base 4x. And we shift to the left 4 units. We got the function we need to find a graph for x plus 4. So, you know, the asymptote for this log function is the y-axis. Since we shift to the left 4 units, the asymptote become will be here. It was the y-axis. But since we shift the mother function to the left 4 units to get this function, so the asymptote, the vertical asymptote, becomes x equals -4. Okay, x equals -4 is the vertical asymptote. It says locate the vertical asymptote first, and then plot the 2 points on the graph. Plot 2 points, okay? So the mother function passes 1, 0, you know, like that. This is the log growth, right? This is log growth because base 4 is bigger than 1. And we just need to shift it to the left 4 units. So the mother function definitely passed through 1, 0. And we shift that point to the left 4 times. 1, 2, 3, 4. So that's the point the graph need to pass through. We need another point. Another point we can do when x equals 0, you know, when x equals 0. When x equals 0, log 4, 4. When x equals 0, y equals log 4 with argument also 4. And that's what? That's actually 1. That's actually 1. Because log 4, 4 is 1. We convert to the exponential form. 4 to the power 1 is 4. Remember, the base to the power log is argument. So when we have a log function whose base and argument are the same, then the value of that log function is definitely 1. So we got another point, 0, 1. 0, 1. 0, 1 is kind of like the y-intercept of this graph, right? Okay, it says 2 points would be enough. Believe you have the tool in the Lumen can help you to draw the graph like this. Okay, yeah, that's the graph. That's the graph. You can use your graphing calculator to help you to see the fact. You can graph the mother function and shift it to the left 4 units. It should be look the same with the red curve. Next one is also to graph. Okay, this one is mother function is log with base 3x. And we're gonna do a vertical stretch by a factor 3 because we have a coefficient 3 in front of the function. And then we have the function we need to find the graph for 3 log with base 3x. So it's a log growth curve, the mother function, and then vertically stretched by a factor of 3. All the y value going to be tripled. It says firstly locate the vertical asymptote, then plot the 2 points on the graph. We can do that. Vertical asymptote does not change. Okay, vertical asymptote does not change. is still the y-axis, Vertical stretch, the transformation vertically stretched by a factor 3 does not change the vertical asymptote. It's still that x equals 0. And also, it will not change the x-intercept when x equals 1. It's actually, hold on. When x equals 1, it's still 0. Yeah. For this mother function, when x equals 1, y is 0, right? Because, let me explain. Y equals log with base 3x. When x equals 1, y has to be 0. That's the x-intercept for log function. And we can convert, this is 1. We can convert it to exponential form, 3 to the power of 0 equals 1. And this is a true statement we are familiar with. So last class, I also give you the curve for log, right? Log function, the basic log function always have 1, 0. I mean 1, 0 as the x-intercept. And that x-intercept, in fact, does not change. Because when x is 1, y value is 0, with the 3 in front of it, when you triple the number 0, you still have 0. Triple of 0 is still 0. So the x-intercept stay the same as well. Okay? And now we need to find one more point. It requires 2 points. The other one we can do 3. Okay? When x equals 3, now we are looking at the given function, this function. It is y equals 3 log with base 3x. So now we're going to let x be 3. We want to let the base and the argument of the log the same. And let's see what's the corresponding y value. Y equals 3 log with base 3 and 3. Remember I said if the base and argument of the log are identical, are the same, then the log equals 1, right? Equals 1. So y equals 3 times 1, y equals 3. So the curve of that function should pass through 3, 3. 3, 3. Yeah, those work you need to get it done on the scratch paper. 3, 3 is right here. And you just draw a log growth curve. It is stretched vertically by a factor 3, so it looks like a taller. Actually, like a taller go up higher. Normally, it's really go down, like a very, depressed. Since vertically stretched by 3, it looks like a happier a little bit. I hope this helps. Yeah, those problems are from Lumen. The difficulty to teach this course, I feeling, is those questions are pretty challenging, in my opinion. And also is with the time, every time we meet, we only have 80 minutes. It's really hard to cover all the topics. Next, write an equation for the transformation log function shown below. Okay. So earlier we have 2 problems. We are given a function. We need to draw the graph. Now for the log function, we are given a graph. We need to find the equation that represents the graph. Okay, this one is going to be challenging. Let me make the graph a little bit smaller and I can see it better. So this seems a log function, log growth function. I can find some important points. For example, 0, 0 here, and then 1, 2 here, and that is 3, 4 here. Okay, that should be enough. 0, 0, 1, 2, 3, 4. You know, log function always, the simple log function always pass through 1, 0, right? That's the x-intercept. And with y-axis as asymptote. So seems our curve is shifted to the left 1 unit. That's very obvious, right? So the function should be shifted to the left 1 unit. So +1 here, okay? +1 here. And we want to also find the, maybe it's vertically stretched. We don't know. We have to figure it out. So I'm going to put a coefficient in front of the function. Coefficient is a, base is b. The argument should be x plus 1 because it seems it shifted to the left 1 unit from a basic log function. And now we're going to use the given 3 points to see if we can find the values for a and b. Let's try 0, 0. Plug in 0, 0. Plugging in x is 0, y is 0. Then we have y is 0 and a log with base b. X is 0, so y, x plus 1 is 1. And log with base b of 1, this is going to be 0, okay? Because only b to the power of 0 gives 1, the argument. If you don't see that, I'm going to spend a little bit of time to talk about it. When the argument is 1 for a log, the result always be 0. If we translate this to, convert this to exponential form, we have base b to the power of log equals argument. And we understand this is the true statement. So this is also a true statement because they are equivalent. And this is the time to remember this conclusion. When the argument is 1, the log is 0. Because only when the log is 0 on the shoulder of the base, you have 1 as the result of the exponential expression. So, that actually doesn't help anything. So that's it. So 0, 0 doesn't really help anything. Let's try 1, 2 though. When x is 1, y is 2, and we have 2 equals a log with base b. When x is 1, x plus 1 is 2, so here's 2. And if we plug in x equals 3, y is 4, then we have y is 4 here, a log with base b. When x is 3, 3 plus 1 is 4. And this is equation 1, equation 2. I'm going to do the same thing, 2 over 1. To the left side, 4 over 2 is 2. Right side, we have a canceled, right? A log with base b 4 and a log with base b 2. A canceled. So we have log with base b 4, log with base b 2. Then we have the left side is 2. Right side is log with base b 4, log with base b 2. And this actually gives log with 2, with base b2. Hold on, this doesn't help us. I think is a true statement. I think we can use base 10. Log, let's try y equals log base 10 and x plus 1. Let's try this. When x equals 0 is 0. When x equals 1 there. So that's 2. When x equals 1 is 2. So the base gonna be b to the power of 2. One comma 2. Okay. Okay, so I think we can do this. So when x equals 0 is 0. When x equals 1 is 2. When x equals 3 is 4. Yeah, this one is the right answer. But how do I make you understand why is that? So I actually did a trial and error and trial here. Because I want a y value be 2 when the x is 1. When x is 1, the argument is 2. So I want to make the base and the argument the same. Then the log equals 1. Then the coefficient has to be 2 to make that happen. Oh, I think I didn't do well today. It's a lot of details, and those graphing problem is a little tricky. While we run out of time, please let me know if you have any specific questions. I would love to repeat some questions that we did today.
I have a question, Professor.
Yes, please.
Yeah, so peradventure we come across all the similar question on exam. How do you want us to like tackle them? Because right now, I'll say concerning the graph I didn't understand anything concerning the graph.
You don't understand the exponential and the logarithmic graph, right?
The graph so far, yeah. Yes. So like
Not at all. It's challenging, but not even a little bit. What about the 4 basic graphs I gave you last time? Those are 4 basic graphs, very important.
Yeah, I'm talking about, no, I know that one. I'm talking about this topic we just started, the logarithm.
Yeah, it's a little bit tricky.
Yeah, because we have similar questions in our Lumen assignment. I have similar questions in my Lumen assignment. I'm tackling it.
This is one of the questions. All my examples are from Lumen.
Yeah.
Yeah. Then you just have to try. You have to try. Because all we have, from what I see, all I have is 0, 0, 1, 2, 3, 4. That's all I have. So definitely the graph is shifted to the left 1 unit. So the argument definitely is x plus 1. The argument definitely is x plus 1. So you're going to have to figure out what do I let the base to be and the coefficient to be, then the other 2 points can satisfy the equation. You don't want to overthink and find an inconvenient number. Just find some convenient numbers. Find some convenient numbers. Yeah. I don't know if I answer your question.
Okay, I'll keep guessing.
It might be, yeah, keep guessing is not a bad idea. Because all we have, look, all we have is, we would not be able to know what is this, you know what I'm saying? We would not be able to know what's this, you know, what coordinates on that point. I mean, this or this. All we know is that the 3 points here, this one, this one, this one, right? It takes a little bit experience in order to get it done correctly. I would say it is kind of challenging. There's nothing given except the graph, and you have to find the equation. That's pretty challenging, to be honest. 4 is actually yeah, you have to do that. Yeah, you have to do that. I think maybe when you work on the problem in Lumen, it might make it easier. I don't know. Maybe you can zoom in. You know what I'm saying? Maybe you can zoom in to find more points. That might help definitely.
I zoom in, like I will sincerely say, because I don't know. Like this one right now, probably now it's just gonna be guessing all through. Maybe when I come across something like this in the exam. So what if I guess and I don't know, I'm not supposed to guess. I'm supposed to like know it, learn, like kind of know it to my understanding. I have to be taught, but I don't know. Because right now, I'm just looking towards the exam. If I come across question like this, if I keep guessing and guessing and guessing.
Yeah, I'm looking at the study guide for test 4.
Yeah.
Let me see if we have similar problems.
Okay.
Yeah, I'm scrolling down. We have 20 questions on the study guide.
Okay.
We do have one, but that is easier. That one is easier. The function below has I can share the study guide for test 4. Yeah, I'm on this page on number 12. This one is not that bad. They give you the structure, you see that? They
Yeah.
give you the function. Yeah, it's a lot easier. This is totally doable. I'm looking at, this one is to graph the given function. Is also doable. Yeah, the graph below shows a transformation of, this is also doable because they give you the function. They give you something to follow. For example, this form. And what we had is possible, and I didn't copy the whole question, so make it difficult. Yeah, those are doable. There are a few questions about graphs, but they are not that challenging. So all that matters most matter is the exam questions, right? The Lumen questions I know is very challenging. That's the reason I use those questions as examples. But you have multiple trial attempts, then you can just try and try again. That's all we can do, right? Good news is you won't have that type of a problem in the exam. All right.
So one question before we leave. I got a link concerning the review. So what do we do about it? Do you want us to send a screenshot?
I'm sorry, what's screen share?
Reviews, because I know at the beginning of the class we talked about something about what's it called? Review, course review. Is it called? Yeah, it's called course review because they started sending links.
Cost review?
Yes.
The links? I have no idea what you're talking about.
TCC started sending link to review our courses because I went through
survey? Survey?
Yes.
You mean extra credit?
Yes, something like that. Yeah, because I got
Did you get
one.
it? Did you get a survey link?
Survey link. Sorry, yeah, it's called survey link. Yes.
Oh, okay.
They
Then
sent
you
one to
complete
me.
it. Okay, guys, very important. You complete it and you take a screenshot and send it to me. Yeah, you are right. I forgot the thing. Then you can get a credit, extra credit. Yeah, I actually won't receive any email, so I don't know when will they send out the emails. So if you have received the survey link, I think there are 2 surveys. So do both and take the screenshot of both and email it to me. Then you have the 2% extra credit. Thank you for reminding me that. Is that clear, everybody?
Yes, it's clear.
Yeah, 2%.
Yes.
2% probably matter to some of you, you know, 2% is a lot. If you have a 68, then 2% make you C, right? Okay, it's 11 o'clock. I have to go to the office. Yeah, feel free to email me. Well, if anything not clear today, I don't really feel good about today's teaching, let me know and we can meet during my student hours. I can explain more. All right.
Okay.
I'll see you guys on Thursday.
Okay.
Thank you. Have a
Thank
good
you.
day.
Bye.
Bye bye.